Hi, eighth graders. I'm going to walk you through instructions on how to complete this Lego molecules activity. Yep, you're right. You get to use Legos to build and model. That's a big key word that I'm going to be emphasizing. Can you model and show how molecules are arranged at the atomic level? Because we obviously can't see with our eyes the atomic level, but we can think abstractly and build models and pretend maybe what it would look like. So that's our purpose today with this activity. If you search right down to this middle part, molecules and compounds, because depending on when you did this, you may or may not have gone through the vocabulary that I need you to know for this. So what's the purpose? What are we doing? When we stick Legos together, if you're thinking, I have no idea what a Lego is, and if you're thinking that, we need to have a conversation with one another. You'll be using Lego pieces like this. And now I don't want you to worry about like how many circles are on the Lego. Just think of one Lego piece as one atom or one element. We can use the words atom and element kind of interchangeably. Okay, so if I say this is one atom of carbon or one element of carbon, that's what I mean. This is it right here. Right? And so when we stick them together, we're modeling a bond between atoms. Bonded atoms are called molecules. So however you stick these together, that's a bond. Don't worry about like when further questions come up, like, oh, does it matter how I attach these? Can it be like this? Can it be like this? Can it be like this? It doesn't matter. You can arrange them however you want to. Okay, so this is a bond. And when we have them stuck together, it is called a molecule. So molecules are the smallest units making up chemical compounds. And you might wonder, what's the difference between an element or atom, a molecule, and a compound? Well, let me show you with Legos. So an element all by itself. Element, one atom. Molecule. And we can have different colors, which would represent different elements attached to this. If we have different elements, so pretend this is like an atom of hydrogen. Compound. Why is it a compound? Because there are different elements attached to these. We have two different ones. Let's say if you had a different color attached, whether it was red, yellow, blue, it'd still be a compound. But we could also call that a molecule as well, because there are simply things attached to one another. So I hope that kind of makes sense. So for something to be a molecule, there just has to be atoms combined. It could be the same color, different color. If you want to be a compound, you have to have different elements attached. Okay. So what you'll be doing today, it's somewhat self-explanatory, but I want to give you some introductory directions. For this first part, before we do that, I should introduce you to the Lego kits. Here's what they look like. And I'd ask that you're respectful to these kits and to the pieces. Well, when your group is finished, please assort them. There's this little diagram that shows you how they should be put in. I understand if some of the piece numbers, because there are specific numbers on here, may not match up exactly. Over the course of the years, I may have either lost a piece or pieces have been accidentally put in other kits. So you'll be working with groups of 4 or 5. You have plenty of pieces for all of you to be working separately. But I ask that all of your Lego pieces get put back in the kit that you took them from. Right? Make sure when you're finished with this, you double check around your desk. Even the most careful student may have dropped a piece. So please make sure check your floors before sealing these kits back up. You'll also notice inside the kit, there are these plastic bags. Like, what are these for? Now, you're going to get to a question that says, put your molecules or your compounds in this bag. Why? So when we put these into a bag, it's kind of simulating that we are combining them together, putting them together, pretending that like you're like pouring water into a glass. That's kind of what you're doing here. You're mixing them together. So then there'll be some questions asking you, when these are mixed together, is it a compound? Is it an element? Da, 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 da. So do the best you can on those. I appreciate the group that's doing this first. You're kind of the guinea pigs right off the bat. Okay. Again, the first thing that you can do, and I don't want you to take too much time in this first part, you get to make up element names. So it could be like Platyvilium or Misdreslium or Gleninium or Bruncinium, or Geeselandium. Yeah, I said Geeselandium. That's a throwback from a while ago, Mr. Geeson. You can pick the color and the symbol. Again, the symbols should be, if you happen to pick, it doesn't matter. So let's say if I did like Platyvillium. Platyvillium, color, well, it's got to be like red. I don't have cardinal red. That's technically one of our school colors. Lego color, red. And you pick the symbol. Let's say if you just did a capital R. Again, it's not lowercase. It would only be lowercase if you did, let's say, like RD for red. The second letter would be lowercase, but it's your choice. It could be just R, but it's not just a lowercase letter. It's bad news. Bears. Okay, pick 4 more. Don't spend a lot of time on this. Don't. Okay, this is just for funsies. Then we get into the meat and potatoes of the activity. I want you to make some compounds. So remember I had made this compound of 2 browns and a white. Let's say if I made this combination, you're not putting like actual element names. It would just be, I would have like brown, brown, white. Okay, brown, brown, white. And then what we have to do here is put the symbols. So this example here for 2 greens and a purple, notice there's a G2. That 2 is called a subscript. That tells you how many atoms of a certain element there are. So if there's just one all by itself, you do not need to put a subscript. That's why there's no P1 here. So my 2, B, or brown, brown, white, you can use this as an example if you want to, would be B2W. Yeah, B2W. And you can pick, then some more. Don't make a compound with like 10, like 10 atoms on it, unless you really want to, because then it'd be like B10 or something like that. Okay, 2 more here, then flip to the next page. Just a couple definitions I just want to make sure that you're aware of. Notice this is where it starts about putting things in a baggie, and it's going to ask you here, after you had made a few different compounds, you may wonder what a mixture is. So a mixture is when we have different elements. Pretend here's a white, or compounds. So we have a different element or compound occupying the same space. So that's like when we put these in a bag, they're occupying the same space. What would this be? Would it be an element all by itself, compound, or a mixture? What do you think? And don't worry if you're uncertain on some of these. Hey, this is just a warm-up activity for us to try. What's your understanding of these terms? Okay. The next one you might need to know what a pure element is. So a pure element is just one element all by itself. So not one atom of an element. So this would be a pure element, but this would also be a pure element. It's the same thing. This would not be a pure element because it has a different element combined. This would be a compound. Pure element, compound. We could also call this a molecule because there's there are things bonded together. You also will need to know what a pure substance is. Like, all right, what's the difference between a pure element and a pure substance? Okay, we have a pure element. So let's say here's a compound. I'm going to make a duplicate of this. Are these the same? Yes, they are. So if we have a bunch of these, they're all the same, occupying the same space. Is it the same substance? Yes, it is. They're all the same. Pretend this is like a glass of water. Is that all one thing? Yeah, it's a pure substance, not a pure element. This would be a pure element if you had a bunch of the same thing occupying the same space. And they can be detached too. If they're the same thing, pure element, pure substance. I'm thinking that's the last, technical term on here. Once you get to the very bottom here on the back, if you happen to get this far, you get to create your own molecule. Okay, out of any Lego pieces, and you kind of can draw what that looks like. Hope you have a little bit of fun with this. Again, this is an introductory activity. Don't feel like